Our Sun, and other stars like it, do not remain exactly as they appear now. Stellar lifetimes are much longer than ours, but like us, they progress through stages of life. The progression of these stages is connected to the formation of the planets and their fate in the events to come, billions of years from now. In this tour, we investigate the life cycle of stars like our Sun. The Sun was born in a dense, cold cloud of gas, similar to this nearby cloud in the Perseus constellation. Within these clouds, gravity causes pockets of gas to collapse into individual stars. Collapse lasts about 500,000 years. A small amount of the gas collapses but remains in a disk around the forming star. Over several million years, the disk may form planets, like those in our solar system. Eventually, the center of the star becomes dense enough to fuse hydrogen atoms into helium atoms. This marks the transition to adulthood, and the star takes its place on the main sequence where it will spend much of its life. The main sequence appears as a band on this diagram, showing stars' brightness or luminosity versus their surface temperature. On the main sequence, a star's luminosity determines its mass, size, and future evolution. After hydrogen burning ends, stars leave the main sequence and move to other regions of the diagram. At 4.5 billion years old, our Sun is middle-aged, and it is still on the main sequence. Over the next few billion years, the rate of hydrogen fusion will gradually increase, causing the Sun's temperature to increase and its radius to swell. This will cause Earth's oceans to evaporate, and the Earth will take on an appearance more like Venus, whose surface is molten. 5 billion years from now, the Sun's supply of hydrogen will run out. Once the hydrogen in its core is gone, the Sun will leave the main sequence and become a red giant star, its luminosity produced by fusion helium atoms. During this stage, the outer layers of the Sun will expand until it is 200 times its current size, or almost 100 million miles in radius. This new size is larger than the orbits of Mercury and Venus. They will be swallowed by the expanding star. If Earth's orbit increases, it will survive, or it may be swallowed as well. The Sun will then resemble Mira, this nearby red giant star. The red giant phase will last a few million years until all the helium in the core also runs out. The Sun will then undergo a cataclysmic upheaval, throwing off its outer layers and contracting to become a white dwarf. The discarded layers are visible as planetary nebulae like this one. The name planetary nebula comes from early astronomers who noticed that these objects look similar to the atmospheres of gas giants like Jupiter. They do not actually form planets. Planetary nebulae do help to enrich the universe with carbon and other heavy elements, such as those that we ourselves are made of. As a white dwarf, the Sun will be about the size of the Earth. Nuclear fusion will no longer occur, but it will still be luminous because its temperature will remain at thousands of degrees. Over tens of billions of years, a white dwarf will cool until it is dim and cold, a black dwarf. The time for a white dwarf to cool completely is longer than the current age of the universe. This means that there are no black dwarfs now for us to observe in order to better understand our Sun's final fate trillions of years in the future.